They call it the Ring of Fire, a dramatic, glittering necklace encircling the Pacific Ocean, forged by fire, smoke, and the unending movement of the Earth itself. For centuries, it's been a source of awe and dread. The Ring of Fire marks the junctions where the Pacific Plate, a colossal slab of Earth's crust, grinds and collides with its neighbours. It's here that mountains rise from the ocean's depths, volcanoes puncture the skies, and earthquakes shake entire regions without warning. Recently, however, scientists have detected something unsettling. The Pacific Plate, that immense foundation, is showing mysterious behaviour. Across this fiery arc, tremors surge in unexpected places. Volcanoes are rumbling in regions where their silence was once the norm. The rules of geology that shaped continents now seem strangely uncertain. This is not just geology as usual. Experts have issued warnings across North America. They caution that the Pacific Plate, the very heart of the Ring of Fire, may be slowly fracturing. If this is true, the resulting shockwaves would not be limited to remote oceanic regions. These effects could resound along some of the most densely populated coastlines on Earth, and may reshape our future in ways we are only beginning to understand. What is happening beneath the vast Pacific? What are the signs, visible and concealed, that humanity now stands at the edge of unprecedented geological change? And if the Ring of Fire truly awakens, what comes next for these restless forces? To answer these questions, we follow the fractures down through the surface into the dynamic heart of our planet's most ominous boundary. Chapter 1: The Shifting Ring of Fire. Looking into the tranquil blue of the Pacific, it's easy to overlook the chaos churning beneath. Yet a sudden uptick in volcanic tremors and earthquake swarms has sent waves of concern through the scientific community. What's behind this burst of activity in the Ring of Fire? The Ring of Fire is not a single fault or crack, but a 40,000-kilometer horseshoe-shaped zone. A violent scar where the Pacific Plate collides with the North American, Eurasian, Juan de Fuca, Philippine, and other plates. Every earthquake, every eruption, is a punctuation mark in a geologic conversation that spans eons. Subduction, the process where dense oceanic crust plunges beneath lighter continental plates, drives explosive volcanic eruptions and powerful earthquakes. This tectonic cauldron took millions of years to form, yet in recent weeks, seismic networks are catching clusters of earthquakes and sudden increases in magma pressure not recorded in decades. The entire ring appears to be flexing, hinting at deep-rooted instability within its sprawling machinery. Scientists are carefully analysing enhanced seismometer data and satellite imagery to detect shifts and strains along these plate boundaries. Some have identified slow slip events, movements too gradual to be felt by humans, but clear signs that stress is being redistributed below the surface. The critical question: are these tremors fleeting disturbances or the early indicators of something vastly larger? What happens in the Ring of Fire rarely stays there for long. Chapter 2: Pacific Plate, Invincible no more. Picture the Pacific Plate as a continent-sized slab of rock, so vast and enduring that it once seemed indestructible. Geologists have long regarded it as a stable, dominant force, drifting northwest and powering the tectonic dance that created mountains and archipelagos. Yet, its fortress-like image is now showing cracks. Why? With such enormous size comes equally enormous stress. The Pacific Plate encounters more collisions, more pressure, and more friction than any other plate on Earth. For decades, the plate was considered the anchor of the Pacific, with strain primarily released along its edges. But satellite GPS and remote sensing technologies have started revealing subtle deformations within the plate's interior. Tiny, persistent warps that suggest a buildup of stress far from the traditional fault zones. This does not mean the center is splitting apart overnight, but it does signify that stress is no longer only a marginal phenomenon. Micro-deformations, slow slip events, and minor intraplate tremors have been documented in areas once thought to be stable. If the Pacific's most enormous slab is developing weaknesses, it prompts the unsettling question: is any region of solid ground truly permanent? Chapter 3. Earthquake Swarms, Silent Alarms. What happens when the ground shakes in unexpected places, far from any mapped faults? What does it mean when swarms of earthquakes flare up in quiet zones, seemingly rewriting our seismic maps? That's exactly what scientists see in several areas within the central Pacific. Instead of earthquakes clustering strictly at plate boundaries, clusters are now popping up inside the Pacific plate, so-called intraplate earthquakes. These are usually small in magnitude, but their location sets off alarms. They hint at deeper tectonic adjustments occurring within what was once thought to be unbreakable bedrock. Earthquake swarms are especially notable. These are flurries of minor quakes rather than a single large shock, sometimes accompanied by faint harmonic tremors, the Earth's low-frequency signals of deep movement. Seismometers can pick up these hints of shifting pressure. While most of these events dissipate without major consequence, their growing frequency and unusual locations are clear reminders that the plate is under stress in unexpected ways. Chapter 4. Volcanic Hotspots, Cracks Beneath Islands. How do volcanoes punch their way through solid rock hundreds of kilometers from any major fault? And why do they do so in the middle of gigantic plates? The Hawaiian Islands are the model example. These islands sit atop a volcanic hotspot, a stream of magma rising straight up from deep inside the Earth's mantle, burning a hole through the moving Pacific plate above. This molten upwelling creates volcanoes like Kilauea and Mauna Loa, far from any boundary or subduction zone. Chemical analyses of their lavas reveal ongoing changes in their mantle source, suggesting dynamic processes deep beneath the plate's surface. But Hawaii isn't alone. Other Pacific hotspots, such as those generating the islands of Samoa and Tahiti, show similar changes. Increased seismic tremor, magma pressure, and occasional new vents appearing on the seafloor. Underwater mapping reveals chains of younger, little-known volcanic cones stretching away from established hotspots, evidence of new cracks and fractures forming pathways for magma. Island-forming eruptions are often preceded by signals visible only to sensitive instruments: ground swelling, subtle temperature changes, unique gas emissions. These are warning signs that the plate's interior is not nearly as uniform as textbooks once suggested. Chapter 5. Microplates, the Shattered Giant. What happens to a tectonic plate when it meets overwhelming force? Does it simply bend and flex, or does it splinter into smaller plates? The Pacific plate is being shaped by just such relentless forces. At complicated junctions, where 3 or more plates meet, called triple junctions, intense stress can shear pieces off the main plate. These fragments, known as microplates, form a growing mosaic around the Pacific's edge. The Easter and Cocos microplates, among others, have been studied for their distinctive rotation patterns and frequent minor earthquakes. These slivers can move somewhat independently from their parent plate. Their boundaries become sites of frequent low-level seismicity and, occasionally, new volcanic activity. As research progresses, it's apparent that over millions of years, the Pacific plate has ceded multiple fragments to this dynamic process, suggesting that the single, sturdy slab is in reality a constantly changing patchwork. Each microplate increases the complexity of the region and adds new variables to the risks posed by the Ring of Fire. Chapter 6. Subduction Zones, Disaster on the Edge. Why are the world's most catastrophic earthquakes centered on the Ring of Fire's edge, where plates meet and one descends beneath another? At the boundaries, the Pacific plate dives below neighboring plates, a process called subduction. As it sinks, friction builds between the plates. When this pent-up strain is finally released, it can unleash mega-thrust earthquakes, which in turn can displace massive amounts of water and generate tsunamis across entire ocean basins. The epic 1960 Chile earthquake, the strongest in recorded history, and the 2011 Tohoku quake off Japan, just two of many in a long sequence, were both products of this relentless subduction. Similar processes drive the hazardous Cascadia subduction zone off the Pacific Northwest coast. The risk isn't just at the moment of an earthquake or eruption. Subduction zones are also responsible for slow, creeping land shifts and long-term changes to sea level and coastline shape. If changes are starting within the plate's interior, the interconnected outer subduction zones could also be destabilized, raising the stakes for populations across the entire Pacific Rim. Chapter 7: History's Lessons. The Ghost of Farallon. Is the possible unraveling of the Pacific Plate truly unique? Or can we peer into the past to find precedents? Tens of millions of years ago, a vast oceanic plate called Farallon occupied the eastern Pacific. It was gradually destroyed as it was consumed by subduction under North America. Its remnants survive today as smaller plates like the Juan de Fuca, Cocos, and Nazca plates. These now fuel some of the most dangerous fault lines on the planet. Sedimentary records and fossils buried deep offshore reveal the effects of ancient megathrust earthquakes, the scars left by the demise of the Farallon. Now, one of Farallon's main remnants, the Juan de Fuca plate, is responsible for powering the formidable Cascadia subduction zone, still considered one of the top seismic hazards in North America. The Farallon's gradual breakup shows that tectonic plates, no matter how vast, are destined to fragment over time, a fate potentially beginning anew in the Pacific. Chapter 8: Hidden Forces. Pressure from below. What could possibly force a plate as immense as the Pacific to change from within? Beneath the surface of the Pacific, powerful upwellings of superheated rock, mantle plumes, push against the plate above. These convection currents are responsible for hotspots, as well as contributing additional stress to the base of the plate. In some areas, this pressure manifests in the form of massive magma chambers, sometimes detected only by subtle seismic or gravity anomalies. When magma is forced upwards, it can open or widen existing fractures, occasionally resulting in new seafloor volcanic eruptions. This process is largely hidden from our senses, but is a crucial driver of long-term geological change. Sometimes the upwelling pressure is enough to create super eruptions, which can alter regional or even global environments. The interplay between the movement of the Pacific Plate and the vast forces beneath ensures that the Ring of Fire is not a simple surface feature, but the visible trace of vast, ongoing processes deep underground. Chapter 9: Stress Transfer, the Domino Effect. What happens when a single fault ruptures? Does it set off a chain reaction? Seismic events along the Ring of Fire rarely occur in isolation. When one segment slips or ruptures, the stress often shifts to adjacent faults or even distant segments, increasing the likelihood of further quakes. This process, called stress transfer, has been documented in multiple seismic sequences. After the 2011 Tohoku earthquake in Japan, for instance, careful analysis revealed that stress was redistributed along several neighboring faults, some of which experienced increased earthquakes and tremors in the following months. This domino effect isn't limited to one country. It has been observed throughout the Ring of Fire, connecting events across vast distances. When the Pacific Plate itself is experiencing new fractures and stress points, the potential for complex, interlinked disasters grows, making preparation and prediction all the more challenging. Chapter 10: The Evolving Ring, a New Frontier. Is the Ring of Fire a final, unchanging structure, or is it transforming beneath our feet? Ongoing research challenges the idea of the Ring of Fire as a stable, fixed boundary. Continuous sonar mapping and deep-sea drilling paint a picture of ever-shifting fault lines, volcanic systems, and evolving boundaries. Oceanic surveys have uncovered hidden rifts, newly emerging basins, and subtle but ongoing changes in the deep crust. These discoveries indicate that the outer edge of the Pacific Plate, and perhaps its entire shape, could look dramatically different in the geological future. The emergence of new microplates, rifts, and hotspots means that the Ring of Fire is an evolving frontier, where new hazards and new landforms continue to arise. For the millions living in this region, the lesson is clear. Nothing about the Pacific's margins is truly permanent. Chapter 11. Megaquakes, unleashing the unthinkable. What will the next big one look like if it arises from a plate already under internal stress? The Ring of Fire has already produced enormous earthquakes, including Chile's magnitude 9.5 event in 1960 and the 2004 Sumatra earthquake and tsunami. Most of these were triggered at plate boundaries. But if internal fractures increase, multiple fault segments could activate together, potentially creating larger, more complex seismic events. Although earthquakes above magnitude 9 are rare, the merging of shallow and deeper fault movement, still a topic of rigorous scientific investigation, could amplify ground motion. The true extent of risk depends on a multitude of factors, but it is clear that increased internal deformation within the Pacific Plate would complicate earthquake behavior in unpredictable ways. Cities along the Pacific Rim, like Tokyo, Jakarta, and Los Angeles, may receive little warning before the next major rupture. Urban planners consider these worst-case scenarios, but there are natural limits to what can be predicted or prevented. Chapter 12. Volcanic chains, unexpected eruptions. Could volcanoes that have long lain dormant erupt due to new fractures inside the Pacific Plate? Volcanoes are ever present along the Ring of Fire, but are not limited to its absolute boundaries. Some eruptions occur hundreds of kilometers away, at hotspots, or along lesser-known faults. Underwater imaging has revealed an increasing number of new, small volcanic cones on the Pacific sea floor, potential proof of magma finding its way through novel breaks in the plate. Submersibles studying these underwater volcanoes have found unique geochemical signatures, suggesting deep mixing of mantle sources. Swelling magma chambers and increasing volcanic tremor in remote areas are warnings being watched closely by geologists. While not all activity will culminate in surface-shattering events, the risk is clear. New volcanic chains could arise in previously calm regions, redrawing maps and presenting new challenges to the Pacific's coastal nations. Chapter 13. Living on the Edge, Human Risk. How do nearly 800 million people secure their futures while living on an unpredictable, shifting geological boundary? The Ring of Fire encircles major world cities, Tokyo, Los Angeles, Manila, Santiago, where dense populations and vital infrastructure mix with high geological risk. Early warning systems, improved building codes, and public awareness campaigns are all used to mitigate the impact of earthquakes and volcanic eruptions. Despite these efforts, the rapid pace of urban growth in some parts of the Pacific means that vulnerability remains high, especially in low-lying coastal areas. Predicting the precise timing or location of a large earthquake or eruption remains beyond current science, forcing communities to rely on resilience and rapid response planning. When the underlying plate shows signs of new instability, these approaches become ever more critical. Chapter 14. The shrinking Pacific, consumed by subduction. Could the mighty Pacific Ocean vanish, gradually swallowed by converging plates? Geological models indicate that, over millions of years, the Pacific Plate is being steadily reduced as its edges are drawn down beneath surrounding continents. This slow process is driven by the relentless onward motion of subduction, oceanic crust sliding under Asia, Australia, and the Americas. Evidence from deep-sea sediments and patterns of ancient rock strata confirms this trend of ocean basin contraction. In the most distant future, This process could reduce the Pacific Ocean to a series of smaller basins, or even lead to the coalescence of present-day continents into a new supercontinent. Ocean circulation, climate, and biological evolution would all be affected by such a dramatic transformation. For now, the steady march of crust into the planet's interior continues. Chapter 15. The Cascadia Threat: Lessons from the Past. What can history teach us about quiet, seemingly stable boundaries? The Cascadia subduction zone, above the Juan de Fuca Plate, lay dormant for centuries before a massive rupture in 1700 sent tsunamis across the Pacific and left indelible marks on the North American coastline. Ghost forests, stands of trees killed by sudden subsidence and saltwater, testify to the destruction. Studies of tsunami deposits and tree ring data confirm a pattern of long, quiet periods, punctuated by sudden, immense earthquakes. Today, researchers monitor the region carefully, understanding that a lack of recent activity is no guarantee of safety. Cascadia's history is a warning for all of the Pacific Rim. Silence can hide immense strain building below. Chapter 16. The Human Era: Engineering at the Brink. How does humanity adapt to a planet always in motion? Cities atop the Ring of Fire rely on sophisticated engineering. Flexible foundations, seismic reinforced bridges, rapid response infrastructure. Codes in Japan, Chile, and California set the global standard, integrating decades of hard lessons from past disasters. Yet no amount of engineering can anticipate every scenario, especially when internal plate fractures and unusual shaking patterns might occur. New construction approaches like floating schools, preemptive tsunami barriers, and adaptive evacuation planning are gaining traction. Ultimately, survival in this dynamic zone relies not on eliminating risk, but on flexibility, redundancy, and the ability to rebuild and recover. Chapter 17. Magnitude Unknown: The Next Generation of Quakes. Could future earthquakes surpass even our worst-case scenarios? Computer models now simulate a variety of complex fault interactions, incorporating the possibility of multiple segments rupturing simultaneously. While no earthquake greater than magnitude 9.5 has been recorded, the theoretical potential for larger events exists, though such scales remain rare and are largely a cautionary tool for resilience planning rather than a prediction. What is clear is that the Pacific's internal evolution increases the number of variables scientists must track. Each new microplate, hotspot, or swarm increases uncertainty. Historical records, inscribed in sediment, coral, and tree rings, remind us that the Earth is capable of more than we have yet seen. Chapter 18. The Unfolding Mystery. The Pacific Plate is restless. Its fractures are multiplying, its boundaries are tightening, and the quiet beneath the Ring of Fire is giving way to new rumblings. For centuries, observers have looked to the boundaries, where plates meet, where volcanoes roar, in search of the planet's secrets. Now, the greatest changes may be brewing further inward, driven by forces we are only beginning to glimpse. As we witness microplates drifting, hotspots blazing new trails, and earthquake swarms challenging old maps, a single truth emerges. The Earth's evolution is never finished. The ground beneath the Pacific and beneath our own feet is less certain than we might wish. History shows no tectonic plate, no matter how vast, endures forever. The Farallon Plate's fate whispers warnings from the depths. The next echoes could originate from the fractures forming today. Nearly 800 million people live in the shadow of this geological boundary. For them, each tremor, plume, and crack is a warning and a mystery. How long until these fractures unite? What marvels or hazards will these shifting seams bring? Only time will tell. One thing is certain, the Pacific Plate's story is not over. Its next chapter is already unfolding, and the Ring of Fire, as ever, awaits its cue. If you're captivated by the ever-changing dramas deep beneath the surface, by megaquakes, volcanic eruptions, and the immense forces that shape our planet. Subscribe for more explorations into Earth's greatest mysteries. Because behind every calm horizon, the next revolution of our restless planet is already beginning.